Welcome to Rges Algebra 2. This is lesson 1.1, talking about sets of numbers. Now, there are a lot of different sets of numbers, and you will want to know these definitions. We start off really in the order that they're developed. Counting numbers we would think about as 1, 2, 3, etc. as we count different objects. This could also be called the natural numbers. Those two terms would be synonymous. Now, to have whole numbers, which actually your chart doesn't talk about, but most books do, we're going to include the value 0. So then we're going to have 0, 1, 2, 3, etc. Now, when we think about negative numbers, we're going to think of if we had a number line, and there's 0, and we think of 1, 2, etc. to the right on the number line, and you've seen these ideas before, we could also have the mirror image of that. In other words, if I started with 0 and went in that direction instead, I would have -1, -2, -3, etc. Negative numbers do make sense to us. A good thing to think about would be temperature. If we start with a base of our scale, 0, it could be we could have it gets hotter and hotter, and it would go up here. But we could also have a very cold day where it would drop below 0, and so this could be -10 degrees, for instance. And so we do experience negative numbers in the real world. Now, altogether, the negative numbers, the positive numbers, or we're talking about whole numbers, right? The negative whole numbers, the positive whole numbers, and the 0. When we combine all those together and we think in terms of this number line, that's the integers. So integers, negative whole numbers, well, or I should say, the positive whole numbers, their negative counterpart, or negative whole numbers, and 0 altogether would be the integers. Okay, rational numbers. Rational numbers comes from the word ratio. A ratio is a fraction. So if I have 3/4, that's a rational number. If I have 0.75, which is what 3/4 equals, right? 0.75, that is also a rational number. This is the fraction form, and this is the decimal form. Any fraction can be converted to a decimal. Why? If I read this, what am I reading this as? 3 divided by 4. So 3 divided by 4 would give me a decimal answer, right? Let's see, 4 goes into 30, 7 times for 28, subtract, bring down a 0, and 4 goes into 25 times. So this, in truth, is 0.75, as we said. When you are dividing a fraction, take any fraction, you're going to have one of two results. You're either going to have what we call a terminating decimal. That means it stops. It divided evenly at some point, however many places I need to go out. It will divide evenly, or it will become a situation where it is repeating. For instance, 1/3. 1/3 is 1 divided by 3. If we have 10, right, we're going to go, 3 goes into 10 3 times, 9, remainder 1, bring down another 0, 3 goes into 10 3 times, and you can see 9, remainder 1, on and on it goes, and this repeats. We would also write that as 0.3 3 with that bar over it, and you've probably seen that before. So we're going to either have a terminating decimal or a repeating decimal, could repeat to one place or two places or whatever, and all of these, what are we talking about? We are talking about the rational numbers. Now note, all those rational numbers would be filling in all the gaps. Whoops, excuse me. Got my eraser on. All the gaps between two integers. So here, 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 here. Those would be filled in by rational numbers. We also have what we call irrational numbers. This would be numbers that could not be defined by a ratio or a terminating or repeating decimal. So what would examples of that be? Examples of that, we're going to go into this more in depth later in the course, but an example of that would be, for instance, our radicals. Square root of 2, square root of 3. Not every radical, square root of 4, can be simplified. 2, 2. So that would not be an irrational number, but these would be irrational numbers. When we find a value for that, for instance, if you plug that into your calculator and you looked at the decimal value, you will find that it is a pattern that is not terminating or repeating. Okay. Another special kind, so for irrationals, we have radicals. We also have special numbers, and one of the most popular special number, these are called transcendental numbers, and one of the most popular that you're probably already familiar with is pi, which we use when we're talking about a circle, and that will probably come up later in the course also. So pi has a very special value, 3.14159, etc., etc. You can memorize it out to many places if you desire, but it, again, does not form a terminating, like 0.75 stop, or repeating, like 0.3333. It's neither one of those. It just has numbers that go on and on. Okay, now, real numbers. Real numbers are the whole group of everything we've talked about so far. In fact, you could think of it as, I don't have no reason to have that there, as everything on the number line, which would be what? The negative numbers, the positive numbers, or I should say positive whole numbers, negative whole numbers, the number 0, and everything between those whole numbers, which would be found by both the rational and the irrational, can both be placed on the number line. So all of that, rationals, irrationals, positive integers, negative integers, 0, combine them all together, and that makes up the real numbers. Imaginary numbers and complex numbers are a little bit beyond the scope of the course, but this would be, we're not going to go further into detail our explanation right now, but imaginary numbers would be square roots of negative numbers, like that. That cannot be placed on our number line. We will talk perhaps some about that at the end of the course, certainly into the next course you would go into in pre-calc. And complex numbers is a combination of a real component and an imaginary component. And that also is a little bit beyond the scope of most of an Algebra 2 class. But know that they're out there and how to define them. You want to be looking again at that chart on the beginning of Chapter 1. He has a very good chart, very detailed chart. I would say the only thing where we're perhaps taking any exception at all is go ahead and learn it this way. Counting, again, another word for counting is natural numbers. Whole numbers would be where we add the 0. And of course the integers would include the 0. Digits, when we talk about digits, this is a little bit basic of an idea, but they're only, think in terms of the symbols we use in our number system. We use the symbols 0, 1, 2, 3, all the way up to 9. We don't need any other symbols. These are our symbols, and these would be called our digits. And of course, that's the beauty of the place value system. So, because we can number all the numbers we ever need just by using these 10 digits. Okay, so go ahead and do your assigned problem set for 1.1 and come back with any questions you might have.